Due to the broken gear in their truck and the inability to find decent secondhand parts, the owner had no choice but to visit a roadside repair shop. Before it broke, the gear could rotate normally, but it became unusable after the teeth broke. To avoid delaying the owner's delivery schedule, the master began repairs immediately upon receiving the gear. Welding the teeth after simply cleaning the gear surface posed no difficulty. The main challenge lay in grinding the teeth's intertooth spacing. To facilitate the shaping of the repaired teeth, the master first had to create a standard reference mold, similar to dental impressions, using aluminum blocks as raw material. Aluminum was chosen for its low melting point. Continuous heating would quickly melt it into aluminum liquid, allowing reshaping. This was why the master didn't directly weld the gear. After all, the tooth gap determined its usability. After heating for 10 minutes, the molten aluminum must be poured while hot. To ensure complete adhesion to the teeth, the master continuously heated and stirred because contact with the excellent workpiece would rapidly cool and solidify the aluminum. After skillfully removing the iron frame, the teeth were perfectly replicated. Next, the master checked against the broken teeth to gauge the welding height accurately. With the data in mind, the master used E7018 welding rods to repair the damaged area. Due to the significant pressure the teeth endure, high hardness, and good flexibility, welding rods were necessary to prevent secondary breakage. Since the tooth spacing wasn't comprehensive, spot welding was used for observation to avoid unnecessary loss due to excessive welding. With the master's skilled welding, the welding of the teeth proceeded smoothly. Since the weld exceeded the tooth data and the teeth couldn't meet usage requirements, the welded edges needed simple cutting and shaping on a lathe. The protruding welds were cut after being securely fixed to the lathe chuck and tailstock. As the master controlled the tool holder's movements, sparks flew as the excess weld was cut away. When the welded edges were ultimately level, any parts not meeting the required height were removed with the thread cutter. This visually revealed differences in the weld. Although a lathe can repair most workpieces, it can't shape gear teeth. Without a high-end planer in the repair shop, the master used a large angle grinder to grind down the protruding welds. Although seemingly tricky and not simple, this operation required the master, even with extensive experience, to repeatedly compare with tooth molds to ensure the triangular teeth remained centered and symmetrically ground to prevent misalignment and render them unusable. With the master's proficient grinding, the entire process ended quickly. When there were no gaps in the aluminum block mold, it meant the broken teeth were ready for use again. So, with the repair completed, do you think this repaired gear will break again?